Hi, I'm Callie Stoskop, and I am a site reliability engineer. This is the Deploy in Public workshop. This is our 10th and final challenge of the workshop, which is pretty exciting. But if you haven't started with 1 through 9, I recommend backing on up and going from the beginning because the challenges build on one another. In this challenge, we are putting everything together and fully automating the deployment of a full stack application using Kubernetes via AWS's managed EKS service. Pretty exciting, right? You'll use GitHub Actions to actually deploy any of the changes to your code to your Kubernetes cluster. And by the end, you'll be feeling pretty cool. Thanks for watching and have fun. All right. I went ahead and Terraform applied my infrastructure here so that way we can get all of our resources to deploy a full stack application to EKS. All right, so I just wanted to show you that that is applied. I went ahead and used, you can see the EKS infrastructure. All right, moving on. So then now we need to configure our kubectl so that way we can use our kubectl commands. Now, technically, we are trying to deploy using GitHub Actions. So using kubectl locally would be for like administrative purposes. It would be so we can check our logs, so we can see what's being provisioned for debugging, okay? But it wouldn't necessarily be to create the actual resources that would happen within GitHub. But we're to get there slowly, okay? The first thing that we're going to do is clean up my terminal. All right, in my terminal, I'm going to go ahead and do sudo nano /etc/host. I'm going to enter my password. All right, and then I'm going to head down to this line. I'm going to get rid of all of this. And I'm going to bring AWS down. I'm going to log in. And I'm going to head to EKS so I can get the endpoint for my EKS cluster. Because my goal is to change my etc host file so that way when I try to hit this endpoint, it redirects me to localhost. Perfect. Now I'm going to type in AWS EKS update -kube config --name coding with Callie -EKS cluster --region US East 1. All right, so now our kube config file has been updated to reflect the current AWS coding with Callie EKS cluster. So we'll do sudo nano .cube/config, and we'll go to this server line here and we'll add a port 3443. And why are we doing this? Because this is the file that defines what happens when we type in kubectl. We're saying that the endpoint it should hit is this one here. And this, as we know, is getting redirected to localhost. So this is really going to be localhost at port 3443. All right, and save. Next, we're going to go ahead and do our port forwarding. So let's look at what that command is again. Also, just a challenge for you on your own, but at this point, anything that you're doing in the terminal, you can write a script for with bash, right? That's exactly what we're doing when we do GitHub Actions versus what we're doing in the terminal. So see if you could write a script that's going to do this work for you. So all you have to do is run the script instead of going through all of these steps. All right, but for now, I'm going to go through the steps. All right, then, nope. Control A gets us to the beginning of the line. And then we can go ahead and edit this. So our bastion host ID is what's going in here. So to get to the bastion host ID, we need to do EC2, find our bastion host, and copy the ID. We'll paste that in there. And we're almost done. We need to still edit our port numbers. So the port number for the EKS cluster is going to be 443, and the local port number that we're going to be using is going to be 3443. All right, so now let's start funneling our traffic. So we're waiting for connections. Let's do open new window. Let's do open new tab instead, so we don't have a million shells. And we can do kubectl get nodes. Perfect. And now we are ready to get deploying. All right, so if you remember last week when we manually deployed this, we were deploying these resources, all right, in this K8s file. So for our API, we have a deployment, a job to run the database migration, and a service. For our front end, we have a deployment and a service, and then we also have this ingress. So if you remember from last week, we need to go ahead and create an ingress controller so that way our ingress actually gets picked up. The ingress controller will just watch for ingress resources to be created, and then when they're created, it will go ahead and set up the forwarding of traffic for us. So we are going to go ahead then and pull in the NGINX controller guide here. And we will see that we can use this kubectl command here to do it. You'll see it's going to apply a bunch of different resources. And you'll also see that, so right now, if I go to EC2, you'll see I have 0 load balancers, okay? Because we don't have any load balancers installed. But now you can see that after everything is created, if I refresh this, now we have a load balancer. All right, so if you actually go and view the load balancer, you'll see that there's nothing there, okay? And the reason why there's nothing there is because there's, usually it says 404. All right, so sometimes it's just not done creating yet, and I just talk too fast, which story of my life. All right, now it says it's running, so let's try it again. Paste this in. Nope. All right, is it running? All right, so let's do k logs. Let's go and take a look at this ingress controller. And then we'll say -n for namespace, and then it's going to be ingress -nginx. Oh, and I typed in K because I normally have an alias set, but now we do not because it's a new terminal. All right, well, I don't see any errors. So let's try this one more time. Just confused because normally we see a, like, there we go. All right, I just wasn't patient enough. So yeah, we're seeing an NGINX error here, 404 not found, because we have nothing, we have no ingress resource defined in our cluster that's saying how we should route that traffic. In order to do that, we would need to deploy all of these files. All right, so when we manually deploy our application, we have to go and run a lot of kubectl commands, right? We have to do 1, 2, 3, 4, 5, 6 in order to create all of these resources. All right, so there has to be an easier way, and there is. We can use Helm. All right, Helm is going to manage all of our resources for us in terms of it will go ahead and create all of our YAML manifest files. All right, so let's go ahead and first install Helm. We need to make sure we have a cluster, all right, and make sure that we have configured kubectl. which we have. I'm going to use Homebrew to install Helm. So I'm just going to say brew install and then Helm. And then it's going to go ahead and download it. All right. Next, in order to make sure that you installed it, you can say Helm version. And you can see that we have a version here. Because we have a version, we are all set to go and use Helm. So I'm actually going to switch over to this other tab that I've gone ahead and bookmarked here. There's a lot of information about like what Helm is and why we would use it. All right. And part of it, part of it is the fact that you can use like variables and functions within your YAML charts, and that will make things a lot quicker, and you can make like different environments and all of this stuff and pass things in during GitHub Actions. And we're going to use very little amount, but we're going to use some of those features. All right. But we're actually going to simplify a lot of that to start out with. I prefer to start with something small and simple and then add on complexity as it gets too difficult to manage. So I truly understand everything that I'm adding. Okay, so in order to create a Helm chart, all right, we have to have Helm installed, which check we do. And then we need to type in Helm create and a chart name. So let's go ahead and try that in our folder. So we're going to say Helm create and then a name. We'll say to do. You can see that it says creating to do, and then we got this folder to do inside. All right, in it we have a values file, a chart file, a Helm ignore, a templates folder, and a charts folder that is empty. All right, so let's go ahead and pull this over. Let's pull this over so we can start understanding what we need to do. All right, so let's get an explanation of what we're doing. The chart.yaml file is where we'll put information related to our chart. That includes the chart version, name, and description, so you can find it if you publish it to an open repository. Now, we won't be publishing ours to an open repository, so we'll just go ahead and make minimal changes. So let's say a Helm chart to deploy our to-do app to Kubernetes. That's fine. Okay. All right, values. This is going to be the file that has the default variables that we're going to use. So let me show you what that means. All right, so here is going to be a template for a deployment.yaml file. All right, if you see, wow, this is a lot more complicated than ours. Okay, but have no fear. So basically here is a function call. Okay, so they have this file here called helpers.tpl that defines all of these functions. All right, I personally in this workshop am not going to worry about this, so I'm going to go ahead and just delete those this file, but basically it helps you to like create standardized names and tags and all of that business. Okay, I would say definitely look into more tutorials about this as you go. I'm also going to delete the tests folder. I just want to simplify this. We can go ahead and delete the deployment file too, but I just want to show you real quick. We have a good example. Okay, so here's a good example. So for image, this is going to be the image for the container that we're going to run for the deployment, right? You can see that it's saying .values.image.repository. All right, so that corresponds to this values YAML file. And .image is here, right? So we're in values.image.repository. So that's going to end up being NGINX. So this here is going to be replaced with NGINX. All right, and then this is going to be the tag, right? So again, this is just it's just getting the value from the values file. So that's going to come in handy with us in the future, because in the future, we're going to need to pass things in to these files. But right now, this is a little bit complicated. So I'm going to go ahead and delete everything out of this templates folder. All right. I'm going to delete this. Could have probably just deleted them all at the same time. All right. And then I'm going to go ahead and move API front end and Ingress. All right. I'm going to go ahead and move all of those into the templates folder. All right. So now for templates, I have my API, which are these. All right. And then I have my front end. Okay. And then my Ingress. All right. And those all are going to live within, what is it, Matt? The Ingress in the templates folder. Let me go ahead and close out of all of these. Sometimes, yeah, sometimes it just gets mad at me. This is confusing to me, but we're gonna. Interesting. I'll go ahead and explain it. All right. So did that fix it? Just changing something? All right, that fixed it. I just had to change something on the file. That was weird. All right, so that we have. All right, I'm going to leave the Helm ignore. That's fine. I'm not mad at it. We already edited the chart. And then values. We don't need anything about service account because we're not going to have a service account. Honestly, we can just go ahead and get rid of all of these, and then I'll just leave the notes because eventually we will go ahead and add something to the values. All right, so now that we have all of our template files, all right, we are almost good to go. Let's keep reading. So templates directory, this is a place where you'll put all your manifest files. Everything in here will be passed on and created in Kubernetes. So basically Helm is looking at this folder and any manifest files, YAML files that are for resources will be created in that folder. All right. Now, how do we host a Helm chart? We're not going to worry about hosting a Helm chart because we are not going to be using this. All right. So here we can go ahead and use this command here in order to actually create all of our resources. Okay. So let's clear my terminal. So we're going to say Helm. And then this basically saying update grade dash install is going to say like if there's no chart right now with the and like if there's nothing installed with this chart, then create it. But because we don't have anything for now, we're just going to go ahead and do Helm install. And then I'm going to go ahead and do the dash help. Okay. And then let's go look at an example. Helm install name and then chart. Okay, and what is chart supposed to, where's an example? Okay, so Helm install. So dash set JSON is like setting a variable, it looks like. Okay, my Redis. Okay, so then path to the chart. Okay, so we would have Helm install to do app, sure, and then the path to the chart, which is /to do. All right, so then you can see that our name of the chart that we just installed is to do app. It was last deployed today at 6:37 p.m. It went into the default namespace. The status is deployed, and this is the first time that we've done anything to this Helm chart. All right, so now that we've done that, we want to go see what it actually did. So we're going to say alias k equals kubectl. All right, so now we can say k get pods and go look. All right, And it says that we have error image pull. And honestly, that really makes sense because we didn't change any of the variables in our file. All right, so let's go ahead and clear that. And what we could actually do now, Helm uninstall. All right, which says it was uninstalled. Okay, so let's actually go change those. Okay, so we have a database migration job, and you can see that it's using our RDS endpoint, but we didn't enter our new RDS endpoint. So let's go get that. Perfect. And then we can throw it in here. Perfect. Then we can go ahead and go to the deployment for the API because that's going to be in there too. And then, do we need it anywhere else? No. Okay, so the next thing that we need is going to be the image. Let's just make sure that's the right image. So let's go to ECR. All right, so API image is going to be coding with Kali API -ECR. Okay, so that's good. And then here, coding with Kali -front end -ECR. Okay, perfect. One last thing that we forgot is going to be to actually, so we want to go to DIP, simple API. You will use whatever you're using. And now we can go ahead and rerun these jobs because we actually need images to build. I got a little bit Helm happy. So we'll build this. I'll go ahead and pause the video until they finish building. All right, so those have been built and we hopefully fixed all of our issues. So let's go ahead and install again. All right, and then we can go to get pods -watch. All right, so right now all of our containers are creating. It looks like our front end is running. Oh, I forgot that we have a lot of replicas here. All right, our API is running. Our migration job is running. So hopefully we see that the, database migration job completed. So then we can go ahead and get my pods and everything looks good. Okay. So now let's go over here and let's refresh the page and we see our to-do list application. Okay, so see how that was a lot easier instead of running all of those kubectl commands. Once we got everything set up and configured properly, we just had to run one command. All right, so that was pretty exciting, right? We got everything deployed with one command. Well, one command after everything is set up. But let's go ahead and let's try to figure out what could make our lives easier, right? So in the last video, you saw me think, oh, I'm good to go, and then realize like, oh, wait, my database endpoint has changed and blah, 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 right? So we need to go ahead and make that a little bit easier. So I'm not going to want to go and edit my code every single time I have a new cluster or a new variable, right? So instead, I'm going to just go ahead and use the values, okay? So I'm going to copy this, all right? And I'm going to go to my values.yaml, all right? So I'm going to say, I'm going to get an example of one. All right. So we're going to just say the name of the variable then. Okay, so we're going to say like database URL. Oh, and it looks like, and then we'll put that there. Okay, so now that we have that, I'm going to go ahead and get rid of that. All right, perfect. So we have our database URL. So let's go over here. And instead of writing out the database URL, I can say, I need, let's go look at how they have that. I already forgot. Right. So just the double. All right, so double brackets, then dot values. So double bracket, then dot values, dot database. Oh, you know what? I actually like that better. Thank you, Copilot. So let's do that. So let's say database is like that, and then host. Perfect. So now we can say DB host is going to be database.host. DB username is going to be dot values, right? So that's going to be this file, then dot database, then dot username, Postgres. Right, and let's do password, also Postgres. All right. So now what's cool about this is when I call the Helm command, I can create all of this and I can pass in the values that I want. So I don't have to go change all of my code. I can just change my variable values in my GitHub repository and then redeploy the actions. All right. Also, if I have the same value once, I can then change it in many spots. All right. And sure, let's go ahead and do this. Sure. And then we're going to call this dot values dot environment. And it's nice because it yells at you and says that that's not defined. So let's go ahead and define it. And we're going to call it production. All right. Perfect. All right. And then the last thing that we can do here is we can go ahead and say that this is going to be values dot API dot image. And then I think it was dot image repo. Sure, repository is fine. And then this will be called dot values dot API dot image dot tag. Yeah, that looks good. All right, it's mad at this though. So curious what the issue is. So I'm actually going to copy this. I'm going to just put it in here. So we need to put it in quotes. All right. Nope. Let's go ahead and get rid of one of those quotes. All right, I'm a little bit nervous that that's not going to get called, but I'm going to leave it and say it's okay. And then we will see because the database migration won't work. All right, so this image gets used in another spot. So we can go ahead and put it into the image here. All right. And then on the front end, we can go ahead and put that there. We'd want to change this from API to front end, and then from API to front end. All right, and that should be good. I don't really see anything else that needs variable. I think that should be fine. And then we're going to want the database. Database host. Database username and database password and database environment. Perfect. All right, so that all looks good. So now let's go finish fleshing this out here. So API image.repository and API image.tag. So we can leave latest, that's fine. But this is not the correct repository. So let's go back and grab it. going to be here. And then let's do front end image repository. All right, this is going to be, just going to paste that in and make sure. All right, that looks good. And then tag latest. All right, so now let's go ahead and open this up. And we are going to say, so I think I have everything defined, but we'll see. We are going to say Helm. Let's try just using Helm install, and you can see that we can't reuse a name. So instead of Helm install, we need to say Helm upgrade. And now it is, see, we are in revision 2, and it went ahead and upgraded us. I also love that it tells me happy helming. I feel like it's very nice of it. All right, so now that we did that, let's go ahead and say kgit pods -w. And you can see that these did not change. All right, this says this was happening 11 minutes ago, and that is true. That is the last time that we did it. All right, so even though we changed a bunch of values, we didn't actually change what any of like the values are. So from Helm's perspective, there was no, what's it called? There was no like change in the manifest files. And so it didn't actually, it's like, hey, sure, I can upgrade this, but wait, I don't see any changes. If I went through and applied each of these things, nothing would happen. Or maybe it did apply all of those things and then nothing happened. Okay. But the moral of the story is nothing actually changed, and that's why it's not working. So there are two ways to do this. One is through versioning with tags, which is what we'll do after we figure out our variables and values. But the next thing would be to go ahead and uninstall and then reinstall. Obviously, there would be downtime for your customers doing this, but this is just going to be the quickest way to double check that we did everything right. Although I guess if none of the values changed, then that would also mean we probably did it right, but better safe than sorry. So now I can do kgit pods -w so that we can see the pods. You can see that we have 3 that we're terminating because that makes sense. We uninstalled. Let's go ahead and take a look again. And you can see that, yep, 27 seconds ago, we had all of this completed and running. Let's go ahead and refresh. And you can see that, yes, everything is good. So we have a solution, right? If we want to make an edit, we can just uninstall and then install, right? But that's not great because in the time between uninstalling and reinstalling, everything's down, right? Our customers cannot access our application. But another issue is that Helm keeps versions, right? So like you saw that success message saying deployment 1, and then when we used upgraded, it said deployment 2, right? And so what's cool about that is Helm has features where you can actually roll back and roll forward between the versions of your deployments. Okay, so you want to use upgrade so that way it can keep track of those. If you uninstall, you're starting from the very beginning, which if you remembered and you noticed in the success message after we did the uninstall and then install, it said version 1. Okay, so we want to be able to upgrade instead, which means that anytime that we are doing a new change to our code, right? So changing our code would not mean any of this needs to be changed, right? Because these are going to use images that are built. So I could change the image, right? And then but then these files would be like, well, I'm getting I already have the latest image. I already ran this, right? But now there's a new latest image. Okay. So because of that, instead of using the tag latest, when we make version changes to our code, we're going to use versioning. Okay. So for API, we'll use v1. And this is just an example because later we're not going to do this exactly this way, but we're going to say tag v1 and then front end tag v1. Okay. So in order to make this work, we're going to have to go to over here, and I'm just going to make sure build front end, we need to go find the image tag here, and we will change it from latest to v1. Then we need to go change our image tag from latest to v1. All right, now we're going to say get status. We want to say in our get ignore that we want to ignore to do slash just for now, because we don't want our values file to get passed in. Okay, so now if we say get status, get add, get commit, and then we will say changed latest tag to version. So now what this is going to do is this is just going to build the updated image, right? But before it was pulling from latest. So these files never actually changed, so it never triggered a repull. So even though the latest image is different, in these files, it said latest, so it's not even going to try to pull the latest. I hope that makes sense. If it doesn't, message in Slack and we can kind of go through it a little bit more and maybe do an example. But anywho, I'm going to go ahead and, well, I'm not going to change anything because that would rerun it. But now if the API image tag is to change from v1 to v2, that tells Kubernetes, oh, there's a change that has been made. Let's go re-pull that image so we can pull the right tag. All right. So when this goes to get this value API image tag, it will go to this file and it will look and see API image tag v1. Okay, let's go check in on that build and see how we're doing. All right, this should be done soon. All right, so let's, yep, all done. All right, so now we can go ahead and say, being lazy, Helm upgrade to do app. All right. And we see this really nasty message. Basically, it says that this job, the database migration job, is invalid because we cannot change the template. Okay. So what does that mean? That means that you cannot edit a job. Once a job runs, it runs. Okay. So we need to have a new job created every time we want a new job. We can't just edit an old job because that job is done, okay? So what we need to do in order to trigger a new job is to change the name of the job. So instead of just saying database migration job, we're going to say database migration job, and then it's saying release name. But I don't fully know, I don't know what release name is. Let me look that up. So let's do Helm chart release name. Describes the release itself with the release name. Okay, so I'm guessing every time a release happens, it gets a new name. All right, so let's try that. We changed this name, so now when it sees that, it's not going to think, hey, you're trying to edit a job. Instead, it's going to think, oh, you want a new job. Okay, something else that we'll want to pass in, and I got this from my debugging when I hit this error before, so don't think I'm like super smart by knowing how to do this. So I found this Stack Overflow article explaining what's happening. They had the same situation as me, and then this person saying an existing job needs to be deleted because you cannot change the template. But they recommended that we add to the spec this line, and that basically says that it will delete this job after X amount of seconds that it's finished. And I'm fine with 10 seconds. Okay, so now we should be able to upgrade. Okay, and you can see that this is revision 3. All right, and we did not have that error. So adding this release name means that we are are creating a new job each time. So you can see this seems to be, oh, to-do app is the release name. That's actually probably not good on our second upgrade, so we'll go ahead and have to do that. And you can see that after 10 seconds, the database migration job terminated. You can see that these files haven't been changed in 2 minutes and 23 seconds, but they did edit at that point. All right. Perfect. Okay, so so release name, I don't think is the right thing because it went ahead and just added to-do app. To-do app is going to be the same each time. So instead, what I'm going to do is I'm going to do .values.api.image.tag. All right, so that way it will put the version on there too. All right, so let's go ahead and change here one more time because we want to test that this worked. So for image tag, instead of v1, we want to do v2. That's going to be for pushing API. And then for v1 here, we're going to change that to v2. Let's go to our values, and we want to change this to v2 and v2. All right, so get status. Let's make sure we understand what we changed. That makes sense. Then we want to do the get add, get commit, and then we want to say changed from v1 to v2. All right, and just to make sure that we're really driving the point home here, let's go ahead and not in the API, let's in the front end change something to our code, right? So instead of it saying what needs to be done, we're going to say what needs to be done test. Okay. So now let's take a look at what we changed. All right, we modified the front end. All right, and added change to front end. All right, and then now let's push. So just a reminder, pushing is just going to build version 3. Changing this values file didn't do anything for the version 2. Changing the file here didn't do anything for because we are manually doing the Helm upgrade. All right, let's make sure I did 2. All right, and 2. Sorry, I think I'm losing my mind a little bit. All right, let's go over here. And I'll go ahead and pause. All right, we finished building. All right, and if you go ahead and look at your, like an API now, you can see that we have a version 1 and a version 2 versus latest just moving up. All right, so let's go ahead now and do our Helm upgrade. All right. Now you can see that we have revision 4. So let's say kgit pods-w. And you will see that we have pods from 7 seconds ago running. We have some pods pending. All right, a database migration job completed. And now you can see that's appended the v2 and we didn't get an error. I have way too many pods for these. So let's just do that. And now you can see that our old API is terminating, our new API is running, our new front end is running. You can see our deployment job is already gone. So everything is working how we thought it was going to work. So let's go over here and refresh. And now we can see that test. All right, so yay us, we went ahead and we used Helm. We used the values to make things a little bit better and easier to update, and we used versioning. All right, so it's a new day. So I had to destroy my Terraform resources yesterday. I went ahead and applied all of my new Terraform resources. You can see that they've all been applied. All right, I went ahead and installed my Ingress controller, and I built up my ECR images. So you can see I have the build. If I go to ECR, see that I have version 2 here and version 2 here. All right, and then I did the final piece of the puzzle where I did my Helm install command to run all of my template files. Okay. So we should be able to go over to EC2. And nope. And grab the load balancer DNS name and check out our front end. Now let's add a test to do. Let's add a test description and add, and it looks like it popped up. We can mark complete and incomplete, and we can refresh the page. Okay. So we have finished the idea of creating the Helm chart and installing all of our template files and deploying essentially manually, right? But as we kind of make changes, we don't really want to have to go through and say, all right, Helm, please update this manually, all right? Because not only would we have to do the Helm command manually, we'd also have to go through and change the version tags, which is a lift, and we'd have to go to the main workflow file and change the version tags here too. So we're lazy. We want to start improving the workflow, and we're going to do that by adding a deployment action in our job and our GitHub Actions workflow. Okay. But you need to think through what exactly you're doing, right? So when you add a deploy job, in our EC2, we used that like send command, right? Specifically to install everything and deploy our application on our EC2 instances. But here, we don't really have the IDs for our nodes. Like, sure, we could go and find our nodes, but we don't, that's not how you would deploy a application to a Kubernetes cluster. So we have to figure out, how do you deploy an application to a private EC2 cluster? Because the only thing that can access the EC2 cluster is from inside the cluster or tunneling through the bastion host, right? So how do we use that kubectl command? How do we use Helm? And there's a few different options that you have. So I would definitely say, please explore those options moving forward. But what we are going to do is we are going to use GitHub Actions, all right, ARC. And that is going to be our Actions Runner Controller, which enables GitHub Action runners on Kubernetes clusters. So as I said before, the only ways to access our cluster is tunneling through our bastion host, which is how we do it locally, right? And the other option is from within the cluster ourselves, okay? So if our GitHub Actions runner, and to remind you what a runner is, let's go look at the code here, right? Each of your jobs runs on a runner, which is just a virtual machine in the cloud that GitHub has. So instead of saying, well, GitHub, you give me a virtual machine and I'm just going to run my commands on it, what we're doing instead is we will be hosting the runner ourselves, all right? And we're going to be hosting that runner within our cluster. And because we'll be within our cluster, then, right, we are capable of deploying our application to our cluster. Okay, so that's just a brief introduction to what we're going to be doing in this the next few videos, but we are going to have to set up our Actions Runner controller, all right, so that way we are ready to deploy via GitHub Actions. All right, so we are going to go ahead and start by installing our Actions Runner controller. All right, but if you see this warning here, this is the documentation that covers the legacy mode of the Actions Runner controller. All right, and if we want the newer version, we have to go ahead and click this link here. So that's just what we're going to do. Okay, we are going to use this quick start. It says we can try it out in 5 minutes. So let's go ahead and give it a try. All right. So Actions Runner Controller, ARC, is a Kubernetes operator that orchestrates and scales self-hosted runners for GitHub Actions. All right. And it's basically going to scale based on the number of workflows running in our repository, organization, or enterprise. So for our needs, we probably don't need to scale because we're probably not going to be running a lot of deployment GitHub action jobs at once. But if you think about it, if you made this at like an enterprise level, right, you could have lots of developers deploying at the same time. They would need multiple runners. So it would be great that they don't have to wait for a runner to use. It automatically scales and creates more runners for what you need. All right. All right, so in order to use the controller, we have to have a Kubernetes cluster, which we do, and we have to have Helm. All right, so I went ahead and ran Helm list -a, which lists all of the Helm charts that we have deployed. All right, so we manually deployed our to-do app, so that's what we have. All right. Now, the process should be pretty quick here to install the Actions Runner controller. So the first thing that we are going to do is install the operator and the custom resource definitions. All right, so we can just copy this whole code here and paste it in. You can see that it's going and getting what it needs, and hopefully we see a deploy message soon. Perfect, we're deployed. And we can see that the release name is arc. All right, so if we say k get pods and we add the -a to get all of the pods, we can see that in the namespace arc systems, we have this controller pod that is running. All right, the way that we would see that pod by namespace would be -n arc systems. All right, and we can see that our controller is running. All right, so let's move on to the next step. So the next step to enable ARC to authenticate GitHub, generate a personal access token classic. All right, so the way that we do that is github.com /settings/tokens. All right. And you can see that I already have a token, but if you were to go ahead and generate a new one, you would generate new classic, you would name your token, and then you would select repo, and then you would go ahead and click this generate token button. All right, after that, you will see the token displayed on your screen and you can copy it and save it so that way you can use it. All right, because once you close that browser, it won't work anymore. All right, so next step, let's go back. And all right, we need to configure our runner scale set. So we need to run the following command in our terminal. All right, so here is the command. So the first thing that we're doing is we are setting up some variables. All right, so I am going to go ahead and pull my terminal to another screen so that way I can, well, I guess we can do the first ones together, right? So we can do installation name and namespace. So paste those in. So if you ever want to see a variable, you can say echo and then $ and then namespace. And it will print out what is saved in there. Okay, so then we want to say that our GitHub config URL and paste that in there. So this is where we actually go and we get the URL for our repository, which should be that. Yeah. And we are going to put it in quotes and paste it in. All right, and then the final one that we need to do is our GitHub pat. All right, so this is where I'm going to pull my terminal off the screen. All right, and I'm going to paste in where it says the little alligator symbol. I don't know what those are called. Pat. I'm going to paste in inside the quotes my personal access token instead. All right. So now I cleared my terminal, but now what I should be able to do is I should be able to copy this command I'll pull my terminal back and paste it in. And it is going to hopefully configure and install what needs to be installed. And it did. So that is exciting. So next, we're going to go take a look then at what is going on by, saying git pods dash namespace. I think it's arc systems. And you'll see that you have your controller running and then you have your listener running. All right. So that just goes through here. Also, we can do Helm list dash A. And you will see that we now have the to-do app, the Arc controller, and the Arc runner listener all set up. All right, perfect. So now we can actually use the workflow. So I'm going to copy this workflow here. So it should just be this because we already have some jobs set up. So let's go up to main and just trying to figure out. So it's like this. Let me post it in. Looks like it's all, there we go. All right, so now let's go ahead and say git status. Don't want to check in to-dos quite yet though. So it should be in my git ignore. Need to do that. All right, so I'm just going to add, I'm going to hard code it. To-do / values.yaml. I don't really know why that's not ignoring it, but All right, so I don't want to commit my values. So I'm actually going to just quickly delete this. Git add, git commit, testing runner. Right. Of course, so I was working, if you're wondering why this is happening, is I was working on the EKS Fullstack, sorry. I was working on the same branch. I was being bad, and then I reverted to a past commit because I went ahead and tried to figure out a bug on something. I should have used a different repo, or I should have created a branch before, but anywho, here we are. All right, so now we are testing our runner. It's going to build our API and front end, but it's also going to request a runner from our Arc runner set. And we will wait to see if that comes online. And hopefully it does. And the runner came online, and now you can see that it succeeded. So you can see that we got the echo, this job uses runner scale set runners. So very exciting. And our job is complete. I am just curious. So okay, git pods dash A. Oh, so yeah, you can see runner. Yeah, a runner came on. I'm curious if it went off. All right. Well, anywho, that is how you set up your runner, and that is how you get it working. I will note that I've had a lot of trouble with the runners. I think what my trouble has been is that I'm doing this on repeat, and so I'm using the same cluster, but then like installing and uninstalling runners over and over. So hopefully you don't run into any of the issues that I did, but if all else fails and something's not working and you can't figure out by debugging, try to use Helm uninstall and then reinstall. And worst case scenario, you can Terraform destroy and start back up afresh if things get a little too dicey. All right, so I went ahead and added the values back in, but this points out a really good point, right? we want Helm, right? So the way that this works is we install using Helm, and we say that we're going to install what's in the to-do folder, all right? And that is how it deploys our application. It goes in and deploys all the files in the templates, all right? The issue with that, though, is that in order to get this to-do folder into GitHub, we would have to remove it from our git ignore. All right. And that poses a problem because we don't want the sensitive data in there. All right. So how do we push this to GitHub? And eventually, right, eventually this job here, Explore GitHub Actions, will be replaced with our deploy job, right? So we need to figure out a way to get our values out of here, all right, and into GitHub, all right? And the way that we're going to do that is using the GitHub variables and secrets. I'm going to be lazy and just use secrets to do all of these, but you could use variables too if you want. I guess we do use variables in here a little bit. Where do we use a variable in our main? Var. Looks like we're not actually using it though. All right, so because we're not actually using it, let's go ahead and delete it. All right. And let's go back to secrets. All right, so we are going to edit this. So for example, we don't need an instance 1 and an instance 2 anymore because we are not deploying to EC2 directly. We are going to be using Helm to run our manifest files. All right, and so we don't need the EC2 instance IDs. All right, the rest of this we should need though. All right, because as you can see, all right, we will need our DB host, right? If you go into our values, you can see that we need a database host. All right, we need a database username and password, and you can see that those are here too. So we already have these secrets, all right? We just need to inject them in during our main file. So what we can do is we can go ahead and get rid of the values, all right, and make strings because we're eventually going to add them in the, inject them into the Helm command, all right? So we can get rid of this and this. All right. I'm going to leave environment production because that's not sensitive. And I'm trying to figure out if I should be lazy or not. Yeah, I guess we might as well. All right, so I'm going to add a new repository secret then for image repository. You can see we have this API image repo. All right, but if you go and look at how we're using it, it's just the repository name. So it's just this part, the coding with Kali -API -ECR. All right, and so that is not what we need. We want the whole list. So could we reconstruct it like we did here? Where we get the registry from the log and ECR output. Yeah, we could. It would be more difficult because we'd have to log in AWS ECR again, and I don't know if we're doing that in the job. So it's going to be easier, in my opinion, to just add a new variable. So we'll say API image URI is what we'll say. And then we will copy this over. Oops. All right. By the way, I already updated my DB host because I ran through this before I started filming. So if you have not updated DB host secret to be your current RDS endpoint, make sure you do that because that's going to be an issue that you'll run into. All right. The password and the username should both be Postgres, so we'll leave that. All right. But now I can turn this into quotes. So it looks silly, but basically what we're doing here is we're defining the values that Helm needs. All right, and then we're going to use the -- set to actually set the values when we install. All right. So then here we're going to copy this, create a new secret, and we will call this, what did we call the other one? API image URI. So we're going to say front end image URI. Right, and then paste it in. All right, perfect. All right, so in terms of versioning, all right, I'm going to go ahead and just leave that there, but just note that that will be a future improvement. But now at least all of the sensitive or account specific details are taken out of values. So that means we can then get rid of these git ignores. All right, I am going to actually just get rid of this whole K8s folder here. So we can remove the K8s. All right. All right. So now we can go ahead and, well, we would be able to push, but right now it's not doing anything. But if we actually, you know what we should do? Let's go ahead and we say Helm list -all. All right, and we can see that we have the to-do app. So I'm actually going to uninstall it. So I'm going to say Helm uninstall, and then we're going to say to-do -. All right, and so that is uninstalled. So let's go and look at the list again. And so we don't have anything. Okay, so now let's figure out how would we build Helm, right, in a way, our Helm command in a way that works. Wait, I think I have one already. Helm set values. All right. So you can see that we can pass individual parameters with the -- set. So Helm install and then -- set foo equals bar and then /my chart. All right, so let's go ahead and clear that. So we're going to say Helm install to-do -app, and then we're going to say /to-do. All right, and then we can go ahead and set, right? So we're going to set database.host. All right, we're going to set that equal to this endpoint. All right, and then we can just keep going. Then data set database dot username is equal to Postgres -- set database dot password equals Postgres, and then -- set. All right, and then we have api.image.repository. Right, and then let's go and grab that ECR. Right, equals this. And then one more -- set API front end dot image dot repository. And then let's copy that and paste it in. All right, so if I go and refresh here, because we uninstalled, we're going to get this 404 not found again. So let's go ahead and reinstall. All right, and it says deployed, and we go ahead and redeploy, and it works. All right, but let's say we uninstall and we leave one of those out or spell it wrong, right? Let's spell it the front end repo wrong. All right, so it reinstalled. If I refresh, you can see now we have a new error that the 503 service temporarily unavailable, and that's because we have an issue with it can't pull our front end. What's another way we would look at that? We could say kubectl get pods, and you'll see that all of our front end pods, it says image pull back off. And then if you say k logs and then go and grab one of the names of the pods, you can say it's waiting to start because image can't be pulled. All right. So in order to fix that, you would need to, so you can do nope, Control A, top to the front of your line. And then instead of install, you can say upgrade. All right, and then Control E to hop to the end, and then dash ECR. And so using upgrade, all right, we can now upgrade our app, and we can see now we're on revision 2. If I refresh, now I can see my app. All right, but the upgrade is going to be important because that's how, if you think about it, we're going to upgrade each time we make a change. All right, so what if you want to use the same command every single time and you don't want to worry about, well, is it my first time? Is it my second time? Well, let's go ahead and uninstall our app. All right, and let's get that upgrade back up, and I'm going to try to guess what the command is because I don't have it in front of me, but it should be helm upgrade and then dash dash install. And so if I got the command right, that should install if we don't have it, upgrade if we do. So what are we trying to test here? First, that, oh wait, 404 not found, so that makes sense. All right, so first we want to see that if I run this command once when I don't have anything deployed, it will work. And then I want to run it again and I want it to upgrade. All right, so you can see to-do app does not exist, installing it now. Whoop, whoop. And so if I then run it again, you can see that it still works. All right, and it says it's been upgraded. Okay, so what I would do, right, is I'd copy or remember that command because that is going to be the main command in our main.yaml deployment job. All right, so we are going to move on to creating our, what's it called? I can't think. We're going to move on to creating our job in our GitHub workflow. All right, and then the way I'm going to do it is I'm going to try to logically think it through from the workflow that we used in the EC2, right? So in the EC2, the way we did it was we built the API, then we built the front end, then we deployed the API, and then we deployed the front end. All right, so the first thing I'm going to think through is, do I need to deploy the front end and deploy the back end in different steps? And the answer is no. We're going to use that one command, helm upgrade dash dash install, and that is going to do it, right? So we just need one job. All right, so I'm going to go ahead and delete all of this, and I'm going to call this deploy. All right, so the next thing that we need is to name it. So we're going to call it deploy to EKS. And then we're going to say runs dash on. And then what was it called? We just had it. So I'm being bad. Runs on arc runner set. Okay, so I'm just going to change this then. I'll call this deploy. And then name deploy to EKS. All right, and we are going to have more than one step in here. So we're going to name the steps. All right. So the first thing that we are going to do, let's go ahead and look at what we do in here. So the first thing that we do in our deploy API to EC2 is configure AWS, then log into AWS ECR, and then we actually run the command, okay? And where we pull from ECR, so that's why we need to log into ECR, all right? And then we run our container, all right? So here, the container is what is or the Docker image is what's providing the code. All right. In our situation with deploy to EKS, things are a little bit different. All right. So if you actually look higher, let's go look at one of our build steps. All right. In order to build the image, we need to check out our code. All right. So try to ask yourself, why would I need to check out my code in the deploy step? I have my image. And that is true. Your image you have, but we need this handy dandy to do folder here. All right, so the first thing that we're going to do in our job is we're going to check out our code so that way we have access to that to-do folder. All right, the next thing that we're going to do, good job, Copilot, is we're going to configure our AWS credentials. All right, so let's just make sure that this matches. Perfect. All right, it automatically added log in to ECR. And I am going to say that, and also this doesn't even make sense. All right, I am going to say that we don't need to log into ECR because we are running, basically what we want to do is the same thing that we want to do in our terminal. And what was that? So we configured kubectl, right? So let's write this out. All right, so we want to configure kubectl. And how do we do that? We did the AWS EKS update -kube-config and command, right? Okay. And then what did we do after that? That was right when we look at Helm for the install. So let's go back to the all right. Okay. So let's go to the doc. Sorry, I feel like I'm explaining this terribly. Quick start. All right, so the prerequisites to using Helm is that we need a Kubernetes cluster, all right, and we need to install and configure Helm, all right, and we need to have kubectl configured. So kubectl configured is going to be a step, but it's not the first step. The first step is to have a cluster. Check, we have that. The next step is to have Helm installed, right? So we are running these commands on a runner, right? And so the runner needs to have Helm installed, but so even though we have Helm installed on our local computer, we don't have it installed on the container that's going to be running these commands, so we need to install it. All right, we need to have kubectl configured, and those are going to be the prereqs to running the command that we run, and then we should be able to run our Helm upgrade command with secrets. Okay. Values set from secrets. All right, so this is like the game plan for what we want in the rest of the jobs. All right, so what do you see? Let's just give this a try, right? So let's call this deploy. All right, and we're going to say run. All right, so we said here that what we wanted to do was install Helm. So let's go back to installing Helm. So Pete's. All right, so we can do it in a few different ways. We're going to do it by script. So I'm going to go ahead and copy the script in, and it's going to not be great, but it is what it is. All right. We don't need the $sign if you were wondering. So this is going to install Helm, right? So that's this first step here. So maybe we could even say something like echo installing Helm. Okay. And sure, we could even call this install Helm. All right. The next thing that we want to do is going to be name. Yeah, let's say configure kubectl and run. All right. And I think we'll do an echo, which we don't really need to, but I'm just feeling fancy now. Configuring kubectl, . All right. So, yep. we are going to run AWS, EKS, update kubeconfig, and then name. All right, so we need AWS region, if we look, is already in our secrets. So that should be fine, but we don't have this K8's cluster name. So I'm going to go ahead and add that. K8's underscore cluster name. And it should be coding with Kali, EKS, cluster. Could you hard code it? Probably, but what if you Terraform apply and choose a different name? Is it easier to update here? Probably. All right, so now that is going to be the second step, configure kubectl. And then now our last step is going to be say install / update Helm chart. Nope. And we will run. Okay. And then we can go ahead and copy this whole guy. And paste it in. All right. So now this is good, but if I go ahead and commit this, right, it's going to also commit all my sensitive data. So instead of doing this, we want to go ahead and replace, replace all of this with secrets._db host. Perfect. Secrets.db username. Secrets.db password. All right. And then secrets.api_image_URI is what I believe I named it. And then one more, if I could successfully. Perfect. All right. So let's go ahead and give this a try. Now, it's not going to work because we have some gotchas in there, but we can try it anyway. The first thing I'm going to do is I'm going to uninstall the To-Do app, just because I want to make sure my GitHub Actions workflow works for installing and upgrading. But other than that, we can go ahead and say git status, git add, git commit, and then we can say added workflow, added deploy job, and then git whoosh. Oof. All right. Git push. I really shouldn't have done this. And then EKS-Fullstack. All right. And then we're going to say git checkout EKS-Fullstack. And then we're going to say git pull. Oof. And we have merge conflicts. Oh, interesting. Looks like our git ignore. Let's accept incoming. All right, and then values. Let's accept incoming. We still have merge. Oops. And then sync. And hopefully we didn't mess everything up. but if we did, it's okay. We'll fix it. All right. So let's go to actions and see how things are going. All right, so you can see that we built our images, yay, but when we deployed, you can see that we have an issue installing Helm, and the issue is that curl command not found. All right, so this runner is very bare bones. It does not have curl already on it. So when we were using Linux virtual machines, those did have curl already on it. But unfortunately, this does not. Okay. So in order to install Helm, in order to use this curl command, we need to, you guessed it, install curl. All right. And that should work. All right, let me go back because I want to make sure I'm not having multiple jobs running at the same time. I'm not, so get status, get add, git commit, added, install, curl, step to deploy job, and then let's push. You should not have any merge conflicts, by the way. So that whole thing of me fixing my merge conflicts, you shouldn't have to worry about. But in general, when you're working on a team, you might have to worry about that. But that came from me checking out a previous commit and then not getting it set up correctly before I started to film. So we are building, and you can see that we are also deploying at the same time. So that's something that we'll need to fix. But right now we're building and deploying the same image over and over with the same image tag. So I'm not too concerned about it, but we'll fix it in a bit. All right, so we're installing curl. All right, we are installing Helm, which yay, that was done. And then we have another gotcha here. Here we have AWS command is not found. And why is that? Well, all right, here we're trying to use the AWS CLI, but we don't have the AWS CLI installed. All right, so we have to go ahead and install AWS CLI. All right, run. I'm curious if that's right. What I did previously is I went and got the AWS CLI information from the AWS CLI site. But now I'm actually just kind of curious to see if this works. So I'm going to give it a go. And if not, we can go look up the docs and add it. Sometimes I like to see what added test install AWS CLI step. Sometimes I like to just try things and see if Copilot has figured out a more readable way for me to do something and learn more about some of these virtual environments. All right. We're waiting for that runner to come online. All right, so far so good. We made it through Helm install before. So, oh, are we okay, it looks like we're installing the AWS CLI. So that's exciting. So we're doing a lot. Oh, we configured kubectl, so that's exciting. Bloop, bloop. All right, but it looks like we have an invalid Kubernetes cluster is unreachable, invalid API version. All right, so I haven't seen this error before. And to me, that's saying that maybe installing AWS CLI following Copilot wasn't the best. So I'm gonna check the docs, which you can go and look at install or update latest version of AWS CLI. And you can see that we also have a curl command that we can use. So I'm gonna try to use this instead. And this will just tell me if that was wrong, what Copilot recommended, or if I have another issue somewhere else that I haven't thought of. All right, so git add, git commit. All right, and then we're going to say added or replaced install AWS CLI commands. And git push. And then we'll go ahead and check. See what's going on with that. All right, waiting for a runner. All right, installing curl, installing Helm. Oh, unzip command not found. All right, so it looks like we also need to install unzip here. Thank you, Copilot, or maybe you're leading me astray. All right, and then let's go ahead and try again. And honestly, this is what a lot of times doing these jobs is like. You just make one change, go and look at what's going on, make another change, go and look at what's going on until you get to it's working, or you get to just, oh, new error. Let me fix this error, and then let's go back at it. Also, could we comment out the building API Docker image and front-end Docker image jobs? Yes, we could. All right. Yay! All right, so it didn't like the way that we installed our, what's it called? It didn't like the way that we installed the AWS CLI. All right, so that worked and we got a check, so that's good. So let's go and look, and it looks like it did in fact work. Let's delete a to-do. All right, so that means everything is working. We can go ahead and do kubectl get pods, and interesting. Are we not connected anymore? Let's reconnect. All right, k get pods -a. Did we put it in a namespace? Kubectl get pods -a. I spelled get wrong. Oh yeah, it's in the Arc runners namespace now. All right, but everything is running. Everything's good. All right, so yeah, if you are wondering why nothing came up when we said kubectl get pods, it's because that automatically looks at the default namespace. But it looks like when we install something using a runner, it goes into that namespace. All right, so that is doing good, but we still, if you haven't noticed, aren't doing different versionings. All right, so I went ahead and cleared out my front end and API repositories. Well, I should have, because I actually was cheating and I was already using something that we're about to do in this video. All right, but now we are all cleared out, all good. And so if we look, we have a few things that we need to fix, okay? So the first thing that we need to fix is we just named this install curl, and we should name this install curl and unzip, just so we are being good. I'm going to remove these echoes because they're not actually helpful for me in terms of debugging, but they were fun for a little while. All right. So now let's take a look at what we would do if we wanted to deploy something, okay? So let's say I want to make a change, okay? So first, let's just start out with deploying our edits. Edited deploy job. All right. Made a mistake because another thing that we need to do is, so we are going to commit this. Oh, okay. Sorry. I'm like losing train of thought. So right now we're running deploy at the same time as build and our build jobs. But the issue with that is before we always had that version 2 image in there. So it was fine. It was just pulling that one. But Copilot is right. We need to have deploy to EKS need, aka wait on build API and build front end to finish. All right. So let's go ahead and get add, git commit, added need step, and then git push. All right, so now if we go and look, scroll all the way up, let's just go over here. Go to our actions. You'll see it looks a little bit differently now. So now we're not going to deploy EKS until we build our image. All right, and we have no image in there, so that's why we need to do it. If before it was going at the same time, we would have been trying to deploy, pulling an image that doesn't exist. All right, so I'm going to go ahead and pause here, and I'll wait for the jobs to stop running. All right, so now we're deploying to EKS. Let's just make sure everything that we did works. We're waiting on our runner to come online. You can do it, runner. Might have to pause again, wait for this runner. I will say self-hosted runners are a little bit slower at getting online than everything else. All right. So now we're installing. Everything looks like it's going fine so far. Let's keep it up. All right, so now you can see it's been upgraded, right? And that is exciting. All right, so let's go ahead and refresh, add a to-do, and yay, everything is working. Okay, so that's great. But now what if we need to make an edit? What does that look like? So let's go to our front end. Let's just go to the app and then let's add edit here. All right, we still have some extra steps that need to be taken. So the first thing that we would need to do is go to values, and we would need to change this to v3 and v3. That's a big step. And then we would need to go and find where we're building and find the image tags and change that to v3. And then find the image tag and change that to v3. And oof, that's a lot of work, right? All to make an edit. All right, you could easily forget an image tag, forget where something is, and then you'd have to worry about that. All right, so instead what we're going to use as our image tag is we are going to use the github.sha. So that's going to take the sha from our commit, and that's going to make that the image tag. All right, that will be unique every single time. All right, and that way it's automated, so I never have to change this workflow now. All right, all I have to do for values then, right, is go here and make that an empty string. All right, and then you have to ask yourself, well, what is using this tag? Okay, so I'm going to do Command-Shift-F, and that can look all over the repo, and then I'm going to type in api.image.tag, and you can see in my files that my database migration job is using the API image tag, right, as the name. And it's also using the tag to get the image, and you can see that the API is also getting that tag. So we now need to add to our list of settings, we need to add the tags, right? So we need to, let's see if it gets it, set API.image tag to the GitHub Sha and set frontend.image tag to the GitHub Sha. And that should be perfect, all right? So now let's do git status, git add, git commit, replaced versioning with GitHub Sha. All right, and then let's push. And hopefully everything works, but this will give us better versioning because everything will be automated. So now anytime I make a change to my code, it's automatically, I don't need to change the main.yaml file, and I don't need to change my value file either. It's all going to work magically, and not really magically because it took a lot of work for us to get here. All right, I'll go ahead and pause until it's all spun up. All right, we're to our deployed to EKS, waiting on our runner. So once that's done, when I refresh, I should hopefully see edit here instead of test. All right. Also note when we were adding it to the front end, you didn't see test in that app file before we edit it. And that's because this is pulling version 2. So whenever I built version 2, I had the word test in there. And then I've gone ahead and built a million times more. But anywho, perfect. We deployed. So let's go ahead and refresh. And now you see edit. All right. And anytime that I make another edit, it will automatically upgrade. So let's just go ahead for funsies. I made this edit without changing any configurations. Exclamation point. All right. Git commit. Added another edit to celebrate. All right. And so now deployment becomes as easy as pushing your changes. Now, do you want to push to your branch that you are making changes on? No, you probably don't. You will want to do a pull request from the branch that you're working on, your development branch. And then once you merge into your main branch, right? But we are using just like this Fullstack branch, just because our EC2 is on the other one. More of the story is I could have cleaned up my structure of my files better. But basically, you would code on your branch, and then you would create a pull request. Another developer would review your code. Once they felt like your code was good, then they would say, yay, approved. And then you would take your branch and you will click merge, and then on merge, that's essentially pushing your code to main, and then that would trigger the workflow. All right. So that is how we would do everything. All right, looks like we're deploying EKS now here. Waiting on the job, story of our life. It's always good to have a good learning book to read on your desk while you're waiting for deployments, because sometimes it really is just making changes and then waiting, and then making a change and then waiting. So yeah, always have a good book to read on the side, so that way you can still keep learning while you're going. Or you could also do other work or debug. All right. It's cool though, because it's kind of like once you get your workflow to work, it's crazy that it's like, oh, this is so easy now, but it's like, wow, that took so long to do. All right, so now our to-do app has been upgraded. Oh no. Woohoo! All right, so that blip, did you see that? All right, where we loaded the page, but nothing happened. That was an issue that is actually great that happened, because that is our next gotcha. and the thing that we are going to cover. We do not want an interruption in service when we make deployment changes. Now, was that interruption in service very minimal? Sure was. But what if the deployment would have failed and one of those things would have broken? Then it would have this would be broken and our customers using our application would not be able to use it. All right, so we sort of saw the problem in the last deployment, right? As soon as I saw that the job finished, I hurried up and came and refreshed the page. All right, but when I refreshed the page, nothing loaded here. All right, so then I had to refresh the page a few more times, and after a few seconds, it loaded. So I kind of want to go over why that was happening and what is so great about using Kubernetes or another orchestrator for your workflow. All right. So what we're going to do first is we're going to just try to take a look at the problem. All right. So I'm going to just change something on my front end again. And then looking at, sure, a list of tattoos or to-dos. All right. I'm not going to worry about what the change is because it doesn't matter. But I said I do git status, git add, git commit, made arbitrary change, okay? Because the point of this is to get the workflow running again. All right, it's been a few hours, so I'm going to go ahead and restart my tunnel. All right, and then I can go ahead and watch on my terminal. So I'm going to go over here. And I am going to do kubectl, get pods, and then -l for label. And then we're going to say tier equals front end. -a. All right. So -a does all namespaces. Okay, so we can see that we have 3 front end deployment pods going. All right, so I'm going to bring this terminal down and I'm going to open up a new window. All right, and then I'm going to use the same command, but instead of doing tier front end, we'll do tier API. All right, and let's pull this over so we can see that it's working. Okay. So then now we're going to add the -w onto it so we can actually watch the pods coming in. All right. And we should be able to see when our workflow is deploying what is happening. So hopefully I don't miss it. All right. So you can see that the front end pod is done building. You can see that the back end is done building. And so now we're moving on to EKS in a second. All right, so I'm going to go ahead and keep this open so that way we can see when the Helm chart gets updated, okay? Because the goal is to see in the terminal what is going on when that health check gets updated. All right. I also probably shouldn't have had 3 replicas of both going on, but such is life. All right, so we're installing curl and unzip. All right, we're installing Helm and the AWS CLI. All right, and so we're just going to be watching here. You should see now we're running the update command. You can see containers are creating, all right, running and immediately terminating. Did you see how that immediately went to terminating? Okay. So we had a new, let me open this up. This one looks good too. Okay. So we had an API container go to creating, and then immediately the API container said running, and then it said 1 out of 1, which then triggered the old version of that container to terminating. All right. And so on. Okay. So the important thing to watch is that 1 out of 1. All right. If that didn't make sense, that's okay, because I think having 3 replicas is a little bit problematic. So let's scale down to 1 replica, and then let's try this again. I really want it to like be clear what's happening. All right, scaled down to 1 replica. All right, so now that is going to go again. Excuse me. All right, so open that up. Let's go ahead and clear my terminal. Let's get those pods back up. So we have those 3 that are running. And then those 3 that are running. All right. So we should see 1 new one come on. Okay. But notice that we have the ready column 1 out of 1. That means that there's 1 container inside of our pod, and that container is ready to get traffic. Okay. So as soon as that container says 1 out of 1, it's ready, that means that traffic, the load balancer, will start funneling traffic to that pod. All right. So what we're looking for is when this pod comes up, okay, it's automatically going to be ready 1 out of 1 and start setting traffic. But the issue is it's not actually ready. Okay, so let's go over to our program. I'm gonna squeeze this over a little bit, right? And I'm gonna get ready to refresh. As soon as I see a pod come up and it's saying ready, that means it's ready for traffic, okay? So that's what we're watching for as this gets deployed. We're watching for a new pod to come up, get started, and it's gonna immediately say 1 out of 1, all right? And as soon as we see that, we're gonna click refresh, and we're hopefully gonna see what we saw in the last video. I'm so nervous. Honestly, what I should have done is just put like a sleep command in so it sleeps for 5 seconds. All right, so did you see? It came up and said running immediately. And unfortunately, it ended up being ready, so we didn't see that. But you can see here that it immediately says running 1 out of 1. And just because it says that doesn't, and then because it's ready, it immediately terminates the other one. All right, so how do we get around this? How do we make this not a thing? Well, what we want to use is we want to use Kubernetes Readiness Probe. All right. So you can see that we have liveness, readiness, and startup probes. All right. We are going to just do I'm just going to do a ready probe. Well, let's actually look. Readiness versus liveness. All right, let's dig into this a little bit. Okay, so readiness is checking that the container is ready. That makes sense. And then liveness takes over after that. Oh, but it turned out not to be like that. Okay, so indicates whether the container is running. If the default state is success, okay, and then readiness is whether the container is ready to accept requests. All right, so I'm going to use a readiness. I would say this would be another area to look into because you have the difference between like, right, your API could be started, but maybe the database isn't configured yet, and different things. But I just want to show you the idea of this is a readiness probe, and this is what's cool about this is what's cool about Kubernetes. All right, so define readiness probes. Sometimes applications are temporarily unable to serve traffic. For example, an application might need to load large data or configuration files during startup. or depend on external services after startup. In such cases, you don't want to kill the application, but you don't want to send it requests too. So basically, we are defining what is going to be like ready, right? What is going to be the definition of ready? So are we ready to start accept traffic when? What? All right. And so here you can see that there is different things that we can do. We are going to use an HTTP probe. All right. So we can use the HTTP GET, and so that will then send a GET request to whatever route that we have. All right, so let's go ahead and close my terminals. All right, and we're going to let's start in the API database. All right. So we can add readiness probe. Yep, HTTP GET. All right. So here we see that we're saying an HTTP GET and the path, we're not doing health. I'm going to just use /API/ for it. But again, this is a good area for you to dive into a little bit deeper about like what the standard is. So typically the standard would be you have an endpoint readies and an endpoint lives, and then those would be the endpoints you use. I'm just showing you an example of like how we can get this to work quickly. Okay. So basically what we're going to say is that after an initial delay of 5 seconds, all right, and then every 5 seconds, okay, we are going to ping /API/, which if you remember is just our hello world route, all right, on port 3000. And if we get a successful command, then yay. If not, we're going to keep doing it. All right, and then we need to define a timeout. So let's look at timeout. Find timeout seconds, number of seconds after which, okay, failure threshold. So here's all of the different things that you can add, right? So success threshold would be the minimum consecutive successes to the probe to be considered successful after having failed. Defaults to 1, okay? Failure threshold defaults to 3. So that's how many times that a probe will be hit and have a fail before it says, nope, this container is not ready to go and we're gone. So I'm going to leave that to the normal default, but I am going to change these. So I'm going to say this can be a period of 1 second and the initial delay can be a period of, let's say 2 seconds. Let's do 2 for both. So basically it will wait 2 seconds after the pod starts to ping the API/endpoint, and then every 2 seconds after it will go ahead and ping. If we get a success first off the bat, then we're going to have it say, bing, we're ready. All right. And then if we get a failure, then it's going to keep pinging until we get 3 failures or until we get, I think it was like 3 successes after a failure. Okay. So now we can go ahead and copy this, all right, to our front end deployment. And then we can just do / and then we'll do /@80. Right? So that is the endpoint that one would hit if they want to load to the front end. So if we get that React HTML page, then we know that we're good to go. All right, so now we can go ahead and say git status, git add, git commit, added readiness probes. All right, and so what this is going to do is this is going to enable us to not send traffic to our pods if the pod is not ready to accept traffic. And so once it is, then we'll switch over, right? And we'll be able to have the new pod taking the traffic. All right, so we're going to repeat the same thing that we did before. All right, it should be easier to read because we only have 1 pod on the front end and the back end now. All right, but so we can see API is ready, the container inside is ready, and it is running. All right, so now we should see a new pod pop up, but we have the delay at 2 seconds. So it's going to take 2 seconds before it starts pinging the pod. And then after those 2 seconds, it's going to do it every 2 seconds. So minimally, we should see a 0 out of 1 for 2 seconds. All right. And then we should see it change. All right. And also, we probably should have changed something on the front end because we could have refreshed and seen that there was no lag. But this should be fine. All right. So hopefully it finishes soon. Well, these are taking a long time to build. Oh, all right. API is done before front end. That was interesting. All right. So now we are deploying. I probably should have left it at 5 seconds to like really drive the point home. But honestly, it's been 15 minutes of me being rattling about this. And you're probably like, all right, Callie, we get it. We understand what a readiness probe is. You can do it. All right, so we should start seeing it soon. All right, so now you can see that the container is creating, the container is running, but do you see how it was 0 out of 1 and then 1 out of 1? All right, API, we have containers creating, containers running, all right, and then 1 out of 1, and then the other one starts to terminate. If you're wondering why it's a list, it's because we're watching it. So like anytime there's a change, it comes in. These are not new pods, right? So we still only have 2 pods. All right. So we need to now go ahead and take a look at, well, what happens if we don't successfully deploy? What if we never get to that readiness status? All right. So what I'm going to do here is I am going to mess up this here. All right. And instead of getting the correct URI, I'm just going to put wrong. All right. So now this will not work. Our front end, okay, git add, git commit dash m, use wrong image. All right. So I am going to head back over here. All right. And we can look at this. It's building again. And then we can go ahead and clear our terminals and rewatch the pods. Why are we doing this? Well, we are testing what happens if a pod never hits the ready container, right? What are we saying here? So we changed the front end image to be wrong. Okay, so the front end will never be able to successfully ping the front end because it will result in an error, right? And so it's looking for a successful response in that request, right? So the ready status for that container down here will always stay 0 out of 1, right? So this is to show why we use Helm, why we use Kubernetes, right? We were able to get to the same point as kind of where we were at a video ago with the EC2, but that doesn't help us with like rollbacks, roll forwards, making sure that the experience is seamless and there's no downtime during updates. All right, and so that's something that Kubernetes can do for us, and especially in a production setting when you have a ton of customers, that's going to be something that you want. All right. Perfect. Let's go ahead and take a look at where we're at in our deployment. Waiting on a runner. All right, so I'm going to go ahead and pause this and wait until we're close. All right. We're installing the AWS CLI. We're configuring kubectl. we're installing and updating our Helm chart. You can see that we have a container creating. Then you can see that we have error image pull. That ready column here is staying at 0 out of 1. All right. You can see that this went ahead and went to running from 0 out of 1 to 1 out of 1 2 seconds later, because we went ahead and got that created. And then we have the 1 out of 1 terminating, so our old pod terminating. All right. In terms of our front end, we once again had an error image pull, and then we backed off. All right. We can take a look now at the API pod, and we don't need to watch, but you can see now we have our new API up and running, and our front end deployment is now working. So you can see that there's still nothing happening here, but if I go and refresh my page, I'm still seeing the old pod because the old pod isn't stopping. All right, so the next thing that we need to look into is rolling back our deployment. All right. So we can use rollback and the release and revision number in order to roll back into our Helm history. All right, so let's stop watching this front end struggle. All right, and let's go give this a try. So if I look here, you can see that my release is to-do app, and then my revision is 8. All right, so I should be able to say Helm rollback. Release is going to be to-do app, and then revision is going to be 9 for the current one that we're at, right? Nope, 8 for the current one, so we want to say 7. All right, release not found. So let's do -- help. All right, so to see revision numbers, run Helm history. So Helm history to-do app. I was hoping to find an example. Release not found. So Helm list -a. I think it's okay. So we do have to do, oh, because I'm not doing the right namespace, right? So let's do -namespace arc runners. All right, so there we go. So you can see that we have this one deployed. All right, so now we can go to, nope, that I had. I guess we'll just rewrite it. So we're going to have Helm, oh, it was in the other terminal. Roll back, release is going to be to-do app, and then the number is going to be 7, and then we're going to do -namespace arc runners. And hopefully this works. Rollback was a success. Happy helming. All right, so let's go ahead and head back to looking at the pods. And you can see that the one from 10 minutes ago is still running. Let's go look at our pods. And you can see that the one, it created a new API, which was the last one, and it's terminating the one. So it officially rolled back, and we have no downtime from our customer. The only issue with this is that this is not within our, we're not automatically doing this in our GitHub Actions. All right. However, we are now quite past our 2-hour limit for this challenge. So I'm going to challenge you to pick up from where we left off. Yes, you can go ahead and run the automatic or run the rollback command in your terminal, but that requires you to watch the deployment. So I challenge you to figure out how to add the automatic rollback to your GitHub workflow. I had a lot of fun doing this deploy in public workshop and all of the challenges. I hope you had a lot of fun too. If you did, go ahead and leave Coding with Callie a review or reach out with any other feedback. All right, I'm going to go ahead and destroy my resources for the last time of this workshop. And I'm going to delete the load balancer here. Oh wait, we're not going to delete. We're going to run the Ingress. Let's run kubectl delete instead. Make sure that we get all of the resources. All right, so let's paste that in. I'm going to do Control A to go to the front, and then you can do Option and then arrow to go over, and then delete. F. All right. Of course. So that's going to delete our Ingress controller. All right, and you will see if you refresh this that the load balancer is gone too. And once we do that, we are then able to Terraform destroy, and everything should get destroyed. So let me bring down my Terraform repo here, and we're going to Terraform destroy. All right. So there's quite a few areas that we didn't get to in this workshop. I really hope that this was a good starting point, though, to get you to understand some different deployment architectures and methods. And I want you to take things from here and keep learning, keep tagging me because I want to see what you learn, but there's lots of areas we can improve on. For example, the Ingress controller. It would be great if we could create that with Terraform or with some other script. It would also be great if all of the configuring kubectl you could automate, and you definitely can with a bash script. All right, something like deploying the actions runner controller, see if you could automate that, see if you can automate rollbacks. All of these things are areas where we could add some automation and make some things better. All right, I would love to see what you work on and grow with. There's also the liveness. There's just so many more things that you can do, and I'm really excited to see it. I hope you enjoyed the workshop.